All right, good afternoon, everyone. My name is Maurice Rabb, and I'm here to talk about my collections framework, HandAxe. I'm Director of Pedagogy at Spantree. We're a boutique software engineering firm based in Chicago. We work on hard problems. We work on cool problems. We hire from time to time if you're interested in joining us. Oh, those are my colleagues, and these are my colleagues. We'd love to work on your projects. All right, so what is HandAxe? What's this pattern language? Why should we care? It's a set of interrelated patterns for thinking about and implementing collections in programming languages. It's a means of transcending individual programming languages and becoming a standard for naming and semantic choices in the development of collections. Design patterns enabled common language for known but sometimes unnamed structures in software. My goal with HandAxe is to create a similar lingua franca for interacting with collections. And lastly, it's my hope that the framework will influence existing and future languages. So why does this matter? Well, collections are a fundamental part of any language that we use. And most collection framework languages are very idiosyncratic. Given that centrality, it would seem that standards are warranted. So why do we need this, and what's in it for you? Have you ever been bitten by unexpected behavior using collections? Hey, have you ever found yourself digging through the docs trying to figure out some obscure parameter or return type? MDN, yes. Shouldn't you really be able to just infer things from the method names? Wouldn't that be nice? Do you have a hard time remembering the difference between shift and unshift? When jumping between languages, do you get whiplash and want to cry because the semantics are different? Okay, so what will I be discussing today? A set of strict conventions for naming aspects of collections, aka grips, using edge-oriented thinking in collections, a method for visually describing collections, using a domain-specific language for composing methods, conventions for managing immutability, prototypal property resolution. I'll give a walkthrough of that because it's necessary to understand how I dynamically implement methods on the fly based on the behaviors that are inferred. And by the way, I'll tell you what these pretty rocks are about. Okay, so my language journey, I started in C, imperative, close to the machine, wonderful, but I got exposed to Smalltalk early, this wonderful declarative language, and then I had to go in Java, and then I had fun in JavaScript, and then I had to go to Ruby, and then back in TypeScript and JavaScript. But I really want to talk about Smalltalk because it was the most luxurious programming experience I've ever had. The experience of writing code was living in the debugger. You would write a method, and you would call a method. And if the method didn't exist, the debugger would open up, and you'd write it right there, and it would save it, and you'd just keep moving. It was amazing. I've not had anything like it since. And the other thing I got spoiled with was this amazing class hierarchy. It just felt like such a treasure trove, particularly the collection classes, rich and well thought out. Also, I just want to say it's important for us to know our history. Smalltalk was the basis of a lot of stuff that we use now and we take for granted. Extreme programming, which launched Agile, test-driven development. Before there was Jest and JUnit, there was SUnit. Refactoring. Wikis came out of this community. Smalltalk took me to U of I. I met Ralph Johnson through Smalltalking, learned more about design patterns, learned the basis of design patterns being in a pattern language, and learned more about domain-driven design, which is a pattern language for larger software engineering patterns. I'll be talking about a pattern language shortly. So languages come and go, and we borrow from the past, but yet in our profession, we're just rushing forward all the time. We're barely paying attention to the past. We're not considering often, as we move so quickly, the decisions we make, how they will impact the future. We can say this generally about stuff we make, but I'm specifically thinking about languages. All languages have warts. Brendan Eich is the first to admit it that mistakes were made. When you make something in 10 days in a fever dream, you're bound to make some mistakes. And he had no idea when he did this that it was going to become one of the most important languages in the world and the basis, a pillar of the internet. Don't break the internet. So just talking about some methods real quick, the meh, the ugly, the bad, the nasty. I'm going to be talking about slice, splice. Boy, those are hard to say. Shift and unshift. Let's get those out of the way right now, okay? So, shift, you take a list and you pull the first one off. Yay. And then unshift, you take a list and you jam one on the front, upsetting the other one at the front. And the way you remember this, or the way I remember it, is I just drop the F. And I'll just leave that as a gross exercise for you. So, just to cut to the chase, in HandAxe, there's none of this nonsense. We have a sensible add first, delete first, push becomes add last, and pop becomes delete last. Okay, and by the way, when I have the JS on one side and the HandAxe on the other, that's when I'm referring to different languages. Now, it's really easy for us to criticize what's done, like what were they thinking? But I really think it's important for us to embody a sense of gratitude and humility. Many people in open source are working on things that are labors of love. Evan Czaplicki, he gave a great talk in 2018 here talking about this. Programming is hard, and I just think we need a spirit of generosity. We can be critical and be kind. It's hard to predict the future. Sometimes we wish we could go back in time and rename a method or change the signature or semantics, and it's hard. Sometimes we need to add a new method, and we really want it, but the name's already taken, or it clashes with semantics that were already there. Forward compatibility is a lot harder than backward compatibility. Why can't we have nice things? I think we all have Stockholm Syndrome a bit. The worst enemy of a better solution is our existing complacency with what's good enough now. So, but I say we can do better. Our software and tools are the home we live in. Let's make them as nice as we possibly can. All right, so let's cut to a pattern language, or pattern languages, a set of interconnected patterns that contribute to a larger whole. Each pattern describes a problem and a solution space. The observed problems and solutions come from the wild. Like, what have we observed people doing? What have we observed in architecture in a pattern language, for example? Together, they create a state of enlightenment for the domain. At least we hope so. And Christopher Alexander of A Pattern Language Frame calls this a quality with no name. I like to call it the Quan. Now, as a caveat, I think HandAxe satisfies most of these, but the third one, it meets the standard a little uneven, so I just beg your indulgence. All right, so a pattern language, what's this? This is the seminal work by Christopher Alexander. It was super influential in the software engineering community. It has 253 patterns of various scales that are interconnected that create a social architectural language. One of my favorite ones is this 125 stair seating. We do this in front of is it the Stifler Theater? Is that how you say it? Stifler, thank you. We would sit out there at lunch and watch the people. This is something that we see in lovely public spaces. All right, so I'm going to proceed moving forward. I'm going to identify some challenges. We're going to use JavaScript as a basis, and I'm going to talk about patterns. And I may do them in reverse order or forward order, but I'll try to bring you along. Okay, but first let's do a dissection of some of what JavaScript does. Let's look at the core collections. Arrays, which are ordered. Strings are ordered and immutable and only hold characters. Sets are no duplicating values. And maps are key value pairs. And so on the right is how I will be representing these various structures throughout the talk. All right, so we have a set which holds values. And we have dictionaries which hold elements which are an association of keys and values. And they're unordered. Okay, let's look at their protocol in JavaScript. It's very small. And I just like to think about unifying what's alike. So they both do size, they both do for each, they both do clear, the same semantics for them. They both do has and delete. And the only difference between them in has in a set is a value, and has in a dictionary is a key. But you can argue that and by the way, I'm using yellow for values and blue for keys. But you can argue that in a set, the key and the value are one and the same. We use a key to look it up. So we can treat it that way, and we can smash these two together. So they pretty much have the same protocol, which is nice. this is in theory again. And we have maps can get a value at a key. So here I'm looking at this chili, and I'm also saying, well, perhaps we could do the same thing in sets. And so I would get that the element at that chili, rather the value at that chili. So we can unify that. Now with set, a map, you can set a value. And so here I want to set the cherries at the avocado. And I could also argue that I could do the same thing. It would just overwrite in a set. And so that's the result that we would get. And we've unified it there. And lastly, we have add. So we can add something to a set. We are adding a value, or an element if you prefer. But the elements of a map are, again, these key value pairs. So we can add those as well and unify. All right, so I just want to talk about that. Like this is, thinking about the various elements and how these grips, if you will, on a collection. Now, array has a much larger protocol. I'm not going to go into it. It's still sparse compared to many, but we're going to talk about position, the brackets and at and slice. Okay, so here we have an array. Okay, we can do absolute positioning using the braces. So at 3, that index 3, I'm going to get back a chili. And at 8, it's off the side, I'm going to get back undefined. And if I go the opposite way, I'm off the other side of the array, I'm going to get undefined as well. And not long ago, they added relative indexing with at. And so we get the same behavior with 3 and 8, as you would expect. But the negatives are a little different. We have a -3 coming off the back end. And that's going to give me broccoli. All right, but let's see now. Let's look at slice. Slice is going to take a section of an array. And so here, let's say we're specifying we want to go from index 2 to 6. And that's going to give us this sub-collection, those 4 elements right there. And what's annoying is you got to keep track of the inclusivity and exclusivity of the indices. I find it, I've got to look it up all the time. I've been doing JavaScript for how many years? House has gotten bit by this. It works for the negative indexing as well. This will give us the exact same set of results. But these semantics, these semantics are hard to remember. So it's challenging to demarcate the proper start and end of a span using indices. We need an easier way to address the proper indexing of an ordered collection. And so remember, slice is declared as start index and end index. But what if instead we say edges? And so here we're looking at indices, and now I'm looking at edges. Indices, edges. We're going to use the fence posts versus the fence beams. And now, all of a sudden, this method makes so much more sense because it's always just going to be between those fence posts. We call that a span. And the thing that we're spanning over is a sub, again, a sub collection. All right, I'd like to say, we use 0 indexing in JavaScript and a lot of other languages, but some use 1, and 1 indexing has its place. I'm not going to get religious about it, but any reasonable framework should be able to handle both of these approaches. And that certainly works the same for spans. So that's our solution. I'm going to jump ahead because I've just stated what it is. All right, so I'm Uncle Momo. I love to teach. These kinds of problems have happened a lot in helping neophyte programmers and junior developers. I taught at U of I, at Columbia College. It's taught for a while at Dev Bootcamp. I have a few students here. Taught many, many students. And now I was at Sprout Social. I'm at Spantry now, doing some teaching as part of my job, which I love. I've been doing this for more than 10 years off and on, probably more. I've worked with countless students and junior engineers. And this is my life's work, working and developing junior engineers, younger folks, and trying to help them develop a better mental model of what they are doing. If you have an inconsistent mental model, it inhibits understanding. And collections, unfortunately, are rife for this despite their importance. So I'm trying to make this easier for lay programmers to have greater confidence in what they're doing. All right, so let's talk about grips now. So we have these collections, and I want to do I want to get the index of it? Do I want to get a value? Do I want to get a key? this is my way of talking about these parts, and I wanted to use a term that didn't clash with, that was not overloaded in computing. So that's why I'm using this. So we use, and so we were talking about arrays, but now we're going to talk about lists, and instead of sets, groups, and dictionaries to avoid naming conflict, because my first implementation is in JavaScript, and I don't want to confuse the semantics. So from now, we're going to be talking about lists, groups, and sets. And so these are the shape of them. And let's go in and talk about the grips now. So I talked about values. We use yellow for values. They all have values. And we have keys. In a list, the keys are the indices. In a dictionary, they're specified. And in a group, they're implied. And they are natural pairs between keys and values. They're the natural pair. And elements, it's easiest to look at dictionary first. The element is the key-value pair. But in a group or a list, you could argue that the value is also an element. And we often use these words interchangeably when we're talking about collections. But I want to be specific about them. And the natural pair of an element is an indice, particularly in ordered collections. And I also mentioned subs, which are a subsection of a collection. And their natural pair is the span for which you define it. Of course, spans are only for ordered collections. All right, and now we also have the idea of ordered groups and dictionaries. We don't have them in JavaScript, but they're convenient to have from time to time a keyed as well as ordered collection. And the grips are shown here as well. So we can use indices to reference elements in them. All right, so challenges. We have these grips as I've defined them. We're reclaiming these words key, value, indice, element, edge span, and sub for a specific meaning. Right? And also, I have a visual language for talking about collections to be more explicit. This description is what we've just seen now. All right, but now let's say we want to compose methods. It's not always easy to tell from a method name what it does. Likewise, it's not always possible to deduce its semantics or method signature from its name, its parameters and return values. We need a way for method names to be unambiguous in communicating what they do and their method signatures. All right, so HandAxe has a vocabulary of nouns. We were just talking about them, grips. And we also have prepositions, at, of, over, across, within. And we can modify, oh, these are locators. I'm sorry, we use these as locators in a collection. And we also have determiners, which are qualifiers for the grips. I want the first value. I want every element. These are naturally paired together. And then lastly, we have verbs, which are the commands that we do. So if we want to do some writing as opposed to just reading, I may say, at last, I want to put something. And each of these commands has a very specific meaning. I'm not going to go through all of them in the interest of time, but they all have very defined semantics about what they mean, nothing more, nothing less. Okay, so accessors don't contain a command word, so we're going to push them off. We're going to slide these over. And with a accessor, we have a input grip that gives me an output grip. Hey, at this indice, I want this element, input to output. I have this key, I want to get this value. At a particular value, I want to know what key is at. We have input grips and output grips. And there's an implicit relationship between what we can expect. Let's start looking at these, okay? So let's look at, which is the simplest. Hey, I've got a list. I want the veggies at 2, which will be an avocado, okay? And this is a natural relationship, again, between an indice and a value. Hey, I want to do of, index of this broccoli. What will it be? It will be 3. Hey, I want to do within. Within is analogous to slice. I want to take a span and tell me the sub that's added. So I would get this avocado and broccoli in this case. All right, let's look at over and across. I'm gonna wipe over across, but they do similar things. They take a sub collection and go to a span. It's the inverse of within. So here we go. So I have this list, the same list. I want to get this sub collection, chili and avocado, makes for great guac. And I would like to know what span is over it. So we see that. And you can see on the left how these, again, how the span and sub are related. Okay, so these are the primary relationships. But, in theory, you should be able to go from any grip to another. I'm not saying that you should do it, but in theory, it should work. It's an orthogonal approach towards gripping. So, again, I talked about qualifiers. Let's talk about those in some isolation. Okay, so we'll talk about the everyone but where. I'm tongue-tied from them. We'll come back to where. All right, so first and last are ordinals. We talk about order with them. They assume an ordered collection. Quantifiers, and we have forward and backward for ordinals. And quantifiers are talking about a multiplicity of things that we like to reach. Each and every being very distinct. We're an all, so like each of you, all the audience. And, what was, let me see if I can just go back quickly. Oh, animation. So the distinct ones can be either internally focused, which is every, or externally. And I'll give examples of these to make it plain. All right, so let's look at the ordinals first. I have a list, good for guac here. I'd like to get the span of the first set of triples. And I'm going from left to right because it's first, front to back. And so I get that span, 1 to 4. Likewise, I can go the reverse way. Oh, and by the way, I want to say, like with most things, going front to back is the implicit. So we don't necessarily need to say first, but we can if we want to. Span over works just as well as span first. Now I can go backward, and I'll get the last triple, which is from the span of 8 to 11. And now let's talk about the multiplicative ones. Every is good. Every is going to look at a plurality of discrete matches. And so here we're going to go from left to right. We'll find one there. And then the next one is there. But sometimes, let's say we want just not each discrete one. We want everyone. We want what? All of them. So here we go. This will give us all in case we need it. I'm not saying we need this method, but if we do want it, we know how to specify it unambiguously. All right, and so these were internally focused. We are iterating over the receiver object, but sometimes you want to iterate over the parameter, so we use each for that. And so in this case, hey, I would like to find this triple, and I'd also like to find the guac and the, what do we call it, the chili. And so it would give me these two results. I am iterating over I'm doing the plurality of the external part versus the internal. So this describes the quantifier qualifiers. All right, so where? Let's talk about where, and what's, wait a minute. Wait. Okay, wait. One name is cool to rule them all? All right. So let's see, where were we? Okay, so let's say I have a list. Sometimes you want to have a condition that defines what we want. So let's say I have this list, and I would say, hey, hey list, I want the peppers. So I can say index of where. I can say, hey, where? Give me where this thing is a pepper, and it's going to give me that first pepper. Likewise, I can go backward. I can get the last pepper. I'm following that conditional. And of course, I can do hey, give me everywhere this conditional is true. And these methods are analogous to find index, find last, and interestingly, filter. And these are okay names, but I would argue that the construction of the names that I have done this way are unambiguous if one understands the relationships of the grips and composability. Okay, so we effectively have a domain-specific language with these keywords as the fundamental parts for composing methods. And I squashed them down there to make some space. Okay, so with a accessor, we talked about this quite a bit. We have location, qualifier, grip, possibly a front grip. And with a setter, we mix an accessor and a command. And let's look at some of these. So let's say we want at last put. Let's see. Okay, so I have this list, this source list. And I say, hey, source list, at your last avocado, let's put some blueberries. And so it finds the last one, that value, and it replaces that value. It gives me the result. And what's cool about this is it works the same with dictionaries as well. It should work the same with groups as well. These are orthogonal for the most part. So I can say, hey, again, give me that avocado value, and there let me replace it with a blueberry. And so, just to look at another, we have within echo. Let's say over a span, I'd like to echo a value. So here I am looking at the span of 0 to 3, and I'm placing a caret at every element within, or rather every value within, and it works just as well on any type of collection. Okay, so we spoke about the challenge. The solution here is a DSL with strict semantics. All right, so now one thing you may notice is a setter always responds with a changed collection. So if I have, for example, a source and I want to add this eggplant at the end, I'm getting a new resulting array with the change to it. This is in the immutable case. It answers a copy with the change. That's also immutable. Now, in the mutable case, let's say this array is mutable, it's going to change it in place and return that same thing. It's always returning a list in this case. It'll always return the instance or the same type of the thing. And yeah, so this is how we do this. And this is known as the command query separation pattern, which was first done in Eiffel. Bertrand Meyer moved this forward. It's been used in KQSR. It's a well-known pattern, and the idea is that you're either asking an object to tell me something about itself, or I'm commanding you to do something, typically a mutation on yourself, or a mutation that's going to create a new copy that is mutated, but yet immutable. So I've just said all this, so I'm going to move on. I say mutability is like a spice. Like, you should lean immutable, but mutability has its place. In HandAxe, immutability is the norm. Invariably, collections are value objects, if you want to think about it from a domain-driven design perspective. But let's not be dogmatic. Some data structures, priority queues, they have to be mutable or they don't make sense. Sometimes internal state of a entity, it needs to be mutable, but it's hidden inside so no one knows. What happens inside me is none of your business. No one touches my liver. All right, but in many languages, mutability is the norm. So in this case, Smalltalk was that way. JavaScript, sadly, is that way. And so when I do this, it is changing in place. And what's interesting, though, is like, okay, if I change in place, what am I returning? Well, with the Smalltalk, I get the thing out that I put in. Okay? In JavaScript, I get out the length of what I did. Okay. I mean, how could this happen? What craziness is this? But the reason is because often people look at methods as an opportunity. I certainly have had, like, if you're changing state, you're like, oh, I got this return value. I can do something with it. And that's mad convenient. But it's problematic because it prevents this command query pattern from being possible, which defeats immutability for the most part, which sucks. So here we go. Let's go back to the ugly. Here we go with splice, where we started. Okay, this is a strange method. It's mad crazy useful, but strange. We're going to take a start, a delete count, and then possibly many items. Blah, blah, blah. And it returns the removed elements, which is convenient. I will not lie. Okay, and slice, remember, it's kind of its pair. It's like, hey, I'm not going to change. I'm just going to access between the start and end edge. I'm calling them edges, by the way. That's the only way I think. I encourage you to use them as well. Okay, it returns the spanned element. But, come on. All right, we live with this. And this is the fabric of our life, unfortunately. Okay, but there's a better way. So here, we are going to talk about, let's look at splice for a second. Okay, so here we go. So I have these chilies that I want to replace from 3 to 2. What the hell does 3 to 2 mean? 3 in this case is that edge. Okay, edges are good. And 2 is I want to go 2 length forward. Let me look at slice at least. At least this makes a little more sense. This is 3 to 5. Okay. All All right, and so I'm expecting the removed part to be equal to this sub that I've just sliced. So we can account on that. And I'm expecting now this array to be changed, and it does what it says it's going to do. But again, come on now. I mean, how many times have I had to look this up after leaving JavaScript for a while? All right, so like I said, there's a better way. So here we have a list, similar stuff. I have a similar sub that I want to put in. I'm going to use a span, and we're going to call this method within replace. Within a span, I want to replace. And we get the result we expect. But, and let me say, like, if I want that, what's going to be removed, I got to get out beforehand, which I just did, because, again, we're going to return the original list has to maintain its integrity unchanged. So we have to get out the new list, the new changed list, immutable as our return value. OK, so let's see. Here we go with, OK, so yeah, one other thing. So let's say you don't feel like digging the remove thing out, or maybe you don't need it. Well, one other way to do it is every setter in HandAxe has this optional handler where it will give you the remove thing or the new result. So you can have your cake and eat it too and still keep it immutability kosher. And again, the original list is unchanged. OK, so years ago, like I said, I was a small talk programmer. I was working in Squeak. And after working for a while, I was like kind of frustrated about add. I was talking about its nature. And it's ubiquitous in the system. It seems as fundamental as salt on popcorn. It's going to be hard to change. And lo and behold, Alan Kay responded to my post, which kind of blew my mind, was super exciting. And he said something that I never forget. This is paraphrased. But a language's selector namespace is its most precious resource. Because once you've done it, it's out there, and those semantics are almost immutable themselves. So we are judicious about naming and semantics. I want things to be unambiguous. I co-opt words from unrelated domains, a la grips, to provide meaning that is not overloaded. OK, so speaking of overloading, what about this HandAxe thing? So what is a hand? Does anyone know what a HandAxe is? Yes. OK, HandAxes are cool. Humanity's first great invention. Oldest stone tools that we know of, a million and a half years old, second only to fire, really. Well, I mean, that we know of. It's hard to fossil record. It predates art. It predates language. One of the most beautifully designed tools ever produced. It is arguably, at least in the fossil record, the first tool that is art, form, and function. We have these things that are called discoid biface HandAxes, which are clearly unusable. They will cut you if you try to use it. But people were making them for fun and beauty 600,000 years ago. There's some evidence that this is an evidence of hardwiring that humanity doing tool making, because you have these disparate groups that didn't have the same culture. And yet, what are they making? HandAxes, much like birds of the same species making nests that look alike who've never interacted. They've been continually improved over the ages, and obviously we get all kinds of amazing stone tools as we move through our life. But most importantly, it is completely devoid of any overloading in the collections or computer science space. There we go. OK, so let's talk about implementation. This is all cute if in theory, but I was like, oh man, can I make it work? You never want to define every method you possibly can, but you want it when you need it. When you need it, you want it to be right. You don't want it to clash. So how can we do this in a dynamic fashion where you don't have to do it by hand? And like I said, the semantics are so specific that it creates an opportunity to have it done automatically. But for us to get in that, I'm going to give you a quick guide tour through prototypal inheritance in JavaScript. OK, so let's say we have some what are these called? Instances of dictionaries and groups and stuff, OK? They all inherit from a common root, a prototype that's associated with the class. Oh my God, I use it so loosely in JavaScript. A constructor, and there's a hierarchy, perhaps. So lists and dictionaries and groups inherit from collection, and then they inherit from thing, and finally get to a root at the top. Okay, so again, I like to use kind again over instead of constructor or type or class because they're all so dang overloaded. What does it mean? It's like multimedia now, okay? So let's say I have a group and I want to call index of on it. So this is the way it's going to work. It's going to say, okay, group, I'm group, I want to call index of. Well, first thing I'm going to do is I'm going to look inside myself. Do I have this property? No, I don't. Okay, let me look at my prototype. Do I have it? No, I don't. Go up to collection. Do I have it? Yes, I do. Fantastic. There's the implementation. I will grab the implementation. I will execute the implementation on myself. I'm getting the value, and I get 2. How beautiful is that? So that's how it works. It works its way up the tree. Okay, so now let's do another example. So let's say I have this list that's composed from very strange, and I would like to go over strange and fill it with loop. Now, I know this method hasn't been made, so what are we going to do? Let's watch what happens. So here we go. We're going to execute overfill. It goes to the list. Is it there? No, it's not. Is it in the prototype? No, it's not. It's not in the collection. It's not in the thing. So it goes up to the root. And the root is a proxy. And so the proxy is going to say, oh, okay, I got this property I don't know about. Overfill. And let's lazy. Does it match what is valid form? And let's say it does. Then we're going to lazily install this method. And so first thing we have to do is parse the method. And that's, I'm going to hand wave here, but we look at the keywords, the locators, the qualifiers, the target groups, the operators. There were no qualifiers or target groups, but we have an implicit grip for them, which helps us compose a method info object, all the goodies we need to know about this method. We pass this out, and now I'm going to create a new method from it. There's some hand waving, some logic, but this one gets sent to a new tuple setter templater. It's going to create this method, and it's going to return this method, and now it's going to put it right in the hierarchy. So it was like it was there from the beginning. And now we're going to let that receiver make use of this newly created method, which it does. And but here it's actually going to execute now. And what's interesting is the way this is done, thinking about design patterns, HandAxe uses deeply the templating method design pattern. We have a template method. It may call other lazy template methods. It does through the process itself again. We have primitive methods, which they all must implement themselves. And it may call other primitive methods as it's going through its process. Okay, but so now we get this result, and the result is what we expect. Strange has been replaced with loop. Okay, all right, so just global gestalt here, like there's only a few dozen primitives that are necessary to possibly compose thousands of possible accessors and setters that meet the semantics and vocabulary, the grammar of HandAxe's collections. Okay, so let's talk about future directions. I need to finish the code. It's probably about 85% there. This summer, I got to the point where it was like, oh my God, like, do I finish the code or do I have something to talk about with you fine people? This is a labor of love, so off I go back to the drawing board as soon as I leave. Handling vacant spaces and collections turns out to be, making the semantics exactly what they need to be, turns out to be shockingly persnickety. More unit tests, of course. Documentation. I really was using JSDoc for documentation, but HandAxe subverts the notion of how classes are figured out by JSDoc. I would love some help with somebody who knows how to do mods on that if anyone has experience. I'd love to switch to Antler for the grammar. We work in TypeScript now. I'd love to re-implement in TypeScript once the JS one is done. But what's daunted me there is the complex generic types and getting types through a proxy if necessary. I have a way to do it without a proxy, but I'd prefer to use it. Lastly, well, not lastly, I'd like to make an automatic visualizer for the language, the visual language that you saw earlier. And, oh, dang it, it jumped ahead, but I would like to do time travel, given the immutability support. Okay, naming matters. My students will remember always me saying that time spent thinking about naming is time well spent. Give your thesaurus a kiss. Spend time speaking to your ob and listen carefully to what you hear. You are not crazy. And what I like to say about this is humanity has been speaking for 100,000, 200,000, maybe 300,000 years. We've been writing for far less. And we've been coding for what? 100 plus years at most. Invariably, I found that the language you use when speaking about your code is far superior to that which you've actually written. So pay attention. Yeah, and so I like to say that, you know, you write the code for the you of 4 months from now. It should be a love letter. It shouldn't just be good. It should be a love letter to your future and your colleagues. And I've spent an inordinate amount of time thinking about and talking to collections, so please forgive me. And that was my thank you. Please send me a note if you're interested. All right, I'm going to have a drink of water and like some questions.